Hi everyone, my name's Adam Brown, and I'm very excited to be sharing some research with you today titled Using Logs Data to Identify When Engineers Experience Flow or Focused Work. This research was done in collaboration with Ciera DeAngelo, Ben Holtz, Ciera Jaspan, and Collin Green as a part of our research on the Engineering Productivity Research Team at Google. The motivation behind this work is that flow is often described as the optimal experience, and at Google we've found it to be no different. Self-reported flow is a positive predictor of feelings of job satisfaction and productivity for engineers. With this in mind, we wanted to develop a passive, logs-based metric to help us better understand how and when engineers experience flow in their day-to-day work. However, when we started looking into existing research, we found that most other attempts at identifying flow required the use of additional sensors or fairly regular survey prompts that ask whether or not an individual is in flow. We hypothesized that both of these could negatively impact the ability for someone to experience flow, which is why we wanted to explore a version of this that was passive and non-intrusive. The research that I'll be sharing today has two phases. The first focuses on qualitative research aimed at understanding what flow looks like for software engineers, and the second deals with the development of our metric, focus time, as well as the quantitative research used to validate it. Everything I'll share today is built on top of fairly robust logging data that spans a diverse set of tools that engineers use to complete their day-to-day work. These logs include things like communication tools such as email and chat, development tools such as IDEs, code repositories, and version control systems, as well as things like intranet and issue tracking. As an example, the diagram here might show an individual on a single day, with time as the x-axis and various tools on the y-axis, with each block representing an interaction. We see that early in the day, the individual is mostly editing code and interacting with a code repository, but later in the day, they are spread across more surfaces, including email and issue tracking. These logs tell us when an individual interacts with a tool and how long this interaction occurs. In the first phase of this work, we asked a sample of 18 engineers to tell us about their experiences each day for a week. Specifically, we asked whether or not they experienced flow, how often it occurred, what they were working on when they achieved flow, and how long they remained in flow. We found that engineers experience flow across a wide range of tasks and durations, not just coding tasks. We also found that once established, flow could withstand some amount of distraction. Most often, the engineers in our sample reported being able to respond to messages from teammates and quickly resume their main task without breaking flow. Finally, and critically for this work, we found that engineers' experience of flow is entangled with their judgment of the progress that they make. This means that the same sets of behaviors might be labeled as flow or not as flow, depending on whether an individual felt they had made good progress on or finished the task at hand. This finding suggested that developing a logs-based metric that captured pure flow states was potentially not feasible in the short term. With this in mind, we expanded our scope to include focused work and adopted the conceptual model shown here. We propose that flow is a distinct subset of focused work, such that an individual only achieves flow if they are focused. We acknowledge that flow has many other nuanced precursors, which we do not attempt to detect in this research, and instead designed our metric to detect instances of focused work that in some cases may be flow, while not attempting to tease the two apart. Based on our qualitative findings, we sought to develop a metric that is agnostic to task, robust to small distractions, flexible on duration, and independent of the value judgment of the work. Instead, we made our metric centered on how related an engineer's behavior is. We call this metric focus time. Our approach requires us to quantify how related behaviors are. In order to do this, we trained a word-to-vec model to generate custom embeddings that can be used to mathematically represent how similar any two behaviors in our logs are to one another. As you can see here, We might imagine that editing code is more similar to interacting with a code repository than it is to interacting with an email client. These embeddings formalize these relationships in mathematical space. After learning how related the logged behaviors are, we leverage the embeddings on the previous slide to generate focus time values. First, we group behaviors into windows of time and take the pairwise cosine distance between all behaviors in a window, normalized by the amount of time spent on each behavior. For the example shown here, we'd expect fairly low distances because the majority of the events are editing code, and the other two behaviors are related to coding work, which represents a high focus. We calculate focus scores for each window of time in an engineer's day. Once we have done that, we go through the data a second time and merge adjacent windows of time with high focus scores. This second pass divides an individual's day into time when we believe they are in flow or doing focused work, and time when they are not. We refer to these divisions as focus time sessions. In the example shown here, we'd merge the first two windows into a single focus time session, which ends at the beginning of the third window because the focus score is low. We validated focus time using diary data. 46 participants recorded the activities they completed for either 1 or 2 days of work, which yielded 97 total diaries. Participants were instructed to complete a diary record after they finished a task and to indicate whether that activity felt in flow or focused. This approach allows us to partition the diary data into time that felt in flow and focused and time that did not, which matches the focus session's data. We used prevalence and bias adjusted kappa, or PABOK, to measure the extent to which the two streams of data agree with one another. Each diary is given a PABOK value, and we report median PABOK across the entire sample. The top chart shows the distribution of PABOK values for our sample. We saw that focus time had a median PABOK of 0.71, suggesting high agreement between the metric and the diary data. We also tested two naive benchmarks that are commonly associated with flow, including periods of high activity, as well as long periods of activity. But in each case, we found the focus metric to substantially outperform these benchmarks. We performed a second validation analysis using data from a quarterly survey. We asked engineers to reflect on the previous 3 months and respond to the question, how often are you able to reach a high level of focus or achieve flow during development tasks on a 5-point scale? We used 3 consecutive quarters of survey results, which due to sampling practices represents a full census of the engineering population at Google and a sample size of over 13,000 engineers. We found that the total number of focus sessions an individual had in a quarter was a positive predictor of self-reported flow. The plot on the left shows the marginal mean estimate on the y-axis and focus session counts on the x-axis. We also found that the percentage of days in a quarter with at least a single focus session was a positive predictor of this survey item, which is shown in the plot on the right. These relationships persisted even when controlling for additional measures of activity, suggesting that focus time is capturing information beyond just how much someone is working. To recap, we defined and developed a new logs-based measure for identifying when engineers experience flow or focused work. This metric is able to identify these states passively and requires no additional sensors or survey prompts. We validated this metric using fine-grained diary data, where individuals were asked to label their experiences as being in flow or focused shortly after they finished a task, as well as on quarterly survey data where individuals were asked to think about the last 3 months. While the current research uses logging data from engineers, we believe that this method can be applied to a wide variety of contexts and populations within HCI that are not limited to engineering practices and engineers. And with that, I'd like to thank you for your time and attention.